of you have used Inventor before. Some of you haven't, which is fine. How many of you have not? A couple. We're going to start at ground level with Inventor and work out, okay? So let me know if I'm going too fast with you, okay? Hopefully it's a small enough class that we can help each other, and we will go through an awful lot of things here. Now,
Mike, your syllabuses look fantastic.
what?
Your syllabuses look fantastic.
They do, don't they?
This is the third one. This is the third one I
Kind
get.
of the same, don't they look?
This is the third one I get today.
I know it. Okay. So, I think there's only two in here who don't know me. I'm Michael Stanquist.
And I've had you years ago.
Okay, I thought you looked familiar. And I've never had you in a class, Don, then. And so hopefully you'll enjoy it. We're pretty low-key, laid back. It's not a stressful class, okay? Unless Holt is in the class, there it is. Okay. 2:30 to 4:20, so just under 2 hours. And so something that we did in our other classes is, remember how long 1040 used to be? 4.5 hours long. We've cut that out now. So they're split, so they're full semester now. So each class is like 2 hours long instead of 4 hours long. And which is a lot easier, you know, in a setting. And so as far as 102710, this is Inventor, the 3D modeling. We will do 3D printing in here. We do have our 3D printers right next door here in this little room right here. We have a sink in there now, so we don't have to run to the bathroom to wash our parts off, okay? And in fact, we're printing the part right now. What is the part? It's a
BB Gun magazine.
Okay. So BB Gun magazine, so we're printing that right now. So I do want you to print something for you in here and design something. Now the neat thing about it is, that we actually printed a bike that actually works now. So remember that?
Oh, wow.
So you guys remember this?
Wow.
Oh, yeah.
It actually works now.
What's the infill on that one, Mike?
It's solid.
Wow.
And we got the thread to actually work. It's a little snug, but it does work.
Was that Jennifer
So
working?
Jennifer worked on that last semester in the
Jennifer worked on that? Yeah. No, the threads. I saw Jennifer printing some smaller threads, and those don't print very well.
Right. Yeah, we did a whole bunch of threads trying to find out what printed and what didn't.
But like the bigger
And
threads,
a lot of threads trying to find
print
taller. So okay. It is. Yeah. And so what we'll be doing in here is, and then a lot of the smaller threads, we're just going to make it and tap them and put regular nuts, screws into. A lot easier than trying to print really small threads because they come up on us. So we'll be doing stuff like that in this class too, okay? I want each one of you to go away with another physical part, okay? And I want you to design it, but I want you to start printing right away. Let's use the printers, okay? I mean, we've let the printer stand still for quite a bit, and I don't care how many times you have to redo something to make it right, okay? Let's figure it out and make it right, okay? Does that make sense? And so,
and these printers are really nice. I mean, it's like you don't even need G code. You feed it an STL file, and it does everything.
It does everything for you.
For you.
Mm-hmm. And so There's no limitations. I just don't want you to build a 7 by 7 by 7 block, solid block. Just don't do that. You know, make it something worthwhile. Okay, so come up with your own little design, and you kind of do that on your own. But don't make it too simple. Make it complicated. Does that make sense? Because if you don't finish it, I know what you've worked on, and at least you've tried something. But do something that's worthwhile for you. So you can, if you want to, you can go home and take away your kids' toys, and just tell them the got ran over or something, you know, because you might not get it back together again if you pry it apart. No, but you know, anything like that. I'd say go home and take apart your wife's appliances and build them, but that probably isn't very good to say either, is it? So, but find something that you can model up.
Well,
okay?
Mike, I mean, look, something really small. You see this purple? You see this purple part? 3D printed, designed 3D printed so that this lens is centered, and then of course I epoxied it, obviously.
Right.
But still, it's an important part. Without it, it was, you know, hell to try to align the lens and get it in the right spot.
And so figure out something you want to do. And if you have any problems, you can come and ask me, and I'll sit down with you and maybe give you a few ideas. But just look around. I mean, everything you have, you can 3D print. And just, like I say, don't make it too simple. We'll go from there, okay?
Something broke at the house, and
yeah. Microwave handle.
yeah.
You ever tried finding a microwave handle nowadays? It's more than the microwave cost in the first place. Just a handle, you know? You can 3D print them, okay? So anyway, for those of you who don't, for Don, basically, you know, my name is Michael Stanquist, and you have my office there. I'm here every Monday and Wednesday all day long, just like I've always been. Okay, and so if you want to come in extra and get extra help, you're welcome to sit in any class I have. Anytime you come in this lab, even if I'm teaching, you're welcome to come in this class. Okay, and as long as I'm not lecturing, then I'll answer questions, even if it's in a different class. So don't worry about that. On Tuesdays and Thursdays, if you need to get in, I'm contemplating coming down Tuesday afternoon if you want some extra help on the side. But if you just want lab time, just ask one of the instructors to let you in, okay? Just do not go to the front desk and ask the secretary, because she will require an instructor to be in here with you and will not let you in. You know, as instructors, we all feel that you're honest, and we will let you in any lab. You know, we just ask you to shut the door and turn the lights off. That's all we ask. Okay. So the main course description is solid modeling with AutoDesk Inventor. Now, Inventor, every one of you can download at home for free. Any AutoCAD product you can download for free at home. Okay. And we found out it does update. You know, you get a 5-year version of it and automatically updated a couple of students last period. And so even though you download it, you know, it'll just automatically update, so you don't have to re-download it every year either, which is really nice. Okay. We're going to start out at ground one on sketching things. So a few of you who have done it before, but I'm going to try to teach you how to do it correctly so that things will work out very easy for you as we go through. We're going to do a lot with GD&T on it also. Now, how many of you have had GD&T?
I'm registered.
You're registered. This will be good for you then. This will really be good for you. Do you remember it all? So
I have the book though.
Well, a few of you, we're going to go and show you how you can implement GD&T on the 3D model drawing, which will kind of help you in your class too. And so we'll implement a lot of that in here. But like I say, I want us to do a lot of assemblies. We're going to do a lot with sheet metal in here. We're going to do, we will get into analysis in here so you can figure out where it's going to break, your stress points. And so that's kind of what we'll be covering in this class.
Or actually has the software to figure that out.
Yeah. Yep. And so, and then we'll make drawings from your model, okay? And so that's basically what we'll be doing in here. And we'll be doing a lot with assemblies. And we'll be doing a lot with threads, creating your own threads like this right here. And hopefully it'll be a fun experience for you. But really, I want you to take home something that you're proud of when you get finished, okay? So just bring me your plan and go from there. The only thing that we will most likely need in here is a set of calipers, okay? And I don't have calipers in this lab, but I'll bring, I do have a few extra pairs. If you want to borrow some of mine, you can, but if you want to bring your own calipers, you know, they're only about $12 at Harbor Freight or something like that. So you can get like 6-inch dial caliper. And so,
Mike, can I say something about it? There's a lot of Chinese calipers on Amazon and places that are not made out of steel. They're made out of, you know, some kind of composite material. And so, you know, I've got one, and it
has a little
feels,
play in it.
yeah, it feels like it's got play in it.
Yeah, don't buy one that isn't like aluminum handle, and I'll bring you in a pair later on that you can see. But like I said, it only costs $12. About so you will be using that quite extensively in this class, because I will give you parts and you will take parts and you put things back together again. Okay. There'll be a lot that I'd like to work on in groups and pairs in here. So you'll pair up with someone and actually work on projects together. And that way we do twice as many assemblies. How's that? And so the more practice you get, the better off you'll be. Okay? And my resolution for this semester is to be good on Canvas. I'm pretty terrible on Canvas. You know, I like to grade with students, you know, but sometimes I get going in a class and forget to grade. And so I want to be very faithful on that if I can starting this semester.
Yeah, I think that was great out of your class.
And so that's how we'll kind of run the class, okay? Now, if you need to get a hold of me on the syllabus, I probably won't answer this phone number because I'll never be down there. I've never sat down at this desk here, this office yet, since I've been out here for over a year. So I'm usually in the classroom. And so just call me on my cell phone, and it is 435-881-1531. And don't be afraid to call me. I leave home at 5 in the morning, so anytime after 5. And I usually get home, well, I go to bed about 2 in the morning, so between 5 and 2, I don't care. You know, try not to call too late, though. I am up, but try not to call late. Okay? Any questions on that? Okay. Let's go ahead and get started. I do have a couple of drawings that we're going to start with, and I want to pick a fairly easy one to start with, if that's okay with you guys. You don't want too complicated of a one to start with, do you? And as we print, we'll be printing to the, what is it, the 712 printer. And here it's the same one we printed to in the other lab. They're exactly the same printers. And so what we're going to do is we're going to draw that dovetail slide. And as we go through, I will be talking about how to set this up correctly. And we will be getting into changing variables and everything in this class too. We haven't done too much with changing variables in the other classes, but we will do a lot with that in here. And so, as we go through here, I know there's a few who are fairly fluent. And if you want a little change in something different, let me know. You can keep your ear open, but let me know. I want it to be fun for you, and so you can help me out with class. So just let me know if you think we're too easy. I don't want to jump into it because it is an intro to modeling, and so I'm not going to just go right to the advanced. So you'll have to give me a feel for, am I too easy? Do you want separate drawings? And if I have to do half and half and do some more intro, a little bit more, I have no problem doing that. No problem at all. So I just want to make it so that everyone feels like you get some class. Okay? Any questions on that?
No, but I do have a question.
Okay.
Is there something special versus employee and student?
Are you in employee?
I am.
Okay, type in S, okay, your username
Yes.
is SLCCI.
Oh, okay.
Now, type
Oh,
right that.
and then my password will be the same.
Yes. Try that.
Hey, welcome. Okay, so that was
SLCCI.
SLCC and then backslash? Okay, thank you.
Yep. Students don't have to do that, just faculty.
Oh,
Okay. So what we're going to do is we're going to do the dovetail slide. See, Don, would you mind writing down down?
Okay. Sure.
Okay. Now, let me turn the lights down just a little bit here. Okay, so I try to hold the lights down, number one, so you can see the screen better. Number two, so you can sleep better if you want to. But, no, if it's too dark, let me know and I'll turn them up a little bit, okay? So hopefully, if we have things, I'll make copies a little bit larger so you can see. I actually went and bought me a little $1.50 little light that I can stick if I need it, so I left it home, of course. So let's go ahead and start with this. And as I do it now, I want you to think about how we lay it out, because everything you need to lay out, you need to follow these same basic principles. You need to say, okay, if you're doing an assembly, where do you want your origin to be your reference point on all the parts? And you want to start designing parts with a reference point or an origin so everything will fit together nicely. Now, can you do it without it? Yes. Are there times that it'll cause problems if you don't do it? Yes, there is. And so just get in the habit of doing it right off. About different planes and work planes and adding different angular planes on and so forth like that. So we'll do all that kind of stuff. Okay? So let's just jump right in. Any questions though before I jump in? No 2D. No, unless you want to. We might do something if it will help us, and we can do them both in AutoCAD and in Inventor. Just to let you, because in AutoCAD you actually physically have to draw the things. Sometimes it's easier to do it, to understand the concept, and then we would do that. Okay? Oh, okay. Mm-hmm. My bigger printer, I'm waiting for it to be recalibrated right now, and they're supposed to come in any day now and recalibrate, then we get it going. But the two small ones are up and going in here.
All right.
Okay?
I have small parts on the
Okay, and we can get going on your small parts too. Okay? Okay, so what we want to do is come in here, and we have AutoCAD Inventor 2020. Now, you have 2019 and 2020. Yeah, 2020 or 2019. Make sure you load 2020. Does that make sense? So just go ahead and double click on that. You guys can see a new picture here. Close this out here and close that out there. Okay? Okay, so you should get to this point. Is everyone is this up on your screen now? Okay. Who does not have it yet? Good. Okay. Now, just hit start working. Okay. In Inventor, you have four different types of files. You have a part file right here. You have an assembly file. You have a drawing file, and you have a presentation file. Okay. Each one of these files have different extensions, and that's how you keep track of them. Okay. Now, a part file is just an individual part. When you combine two or more parts, you have what's called an assembly, okay? Now, when you have a part drawing, you need part file, you need to get a drawing out of it so you can create a 2D drawing out of a part right here, okay? And then if you want to do an animation of it or a different exploded isometric or anything like that, then you have what's called a presentation. And then we go into the presentation. Now, we'll be using all four files in this class. So you'll learn how to do all four of them, okay? And then as we do maybe I'll come up with Monday, just a quick little thing that we can all generate and put your initials in it. I'll show you how to emboss it. And then we can hurry and print it out so you have, you can see actually the full process about creating part, STL it, and everything else. And we'll just print something very simple. So I'll come up with a little project for Monday that we'll print. We printed cars, and this summer we made about 80 of those little spring cars this summer with different groups of kids. And yesterday we just finished another 8 and sent them over to China. We had a group of about 24, 25 Chinese kids here who could not speak English and had to teach them Inventor in a day and a half. And they had to create parts in a day and a half. And we made it. They all did it. And so actually the principal of the school couldn't even speak English. She was over here with them. So it's kind of fun, Fortunately, we have some pretty good interpreters for us. But teaching through an interpreter was kind of fun, too. And so, anyway, so what we're going to do is we're going to start right off the bat with part. So click on the part right here. Okay, so here's your main, outlay for Inventor right here. Now, those of you how many of you have Inventor at home now? Do you have it, Don, at home?
Not currently. I can put it on.
Okay, you do, Rebecca, don't you?
Yeah.
Holden, you guys have it at home? Okay, if you do not have Inventor at home, I recommend you get Inventor at home to play with. It's free. So why not? Now, if you don't want to download it, you can go to All Access and use it. Now, All Access works good now, okay? Last semester, fall semester, summer semester, it did not work. Spring semester, it did not work very well, okay? But they have a new server now, and it's supposed to be state-of-the-art server, so they guarantee me that the CAD will work just like you'd be using it in the classroom. That's what they tell me. Now, I haven't seen it work, okay? Before, you'd push a button and wait, then do a command, wait, and wait. But they say it's supposed to be really good right now. So don't be afraid to go into All Access and use it. So you can either do All Access or just go to AutoDesk.com and download the software on your own computer at home. And that way you'll actually have it at home that you can work on a computer. You aren't going through the internet or anything else. You're working off your computer only at home. So either way you want to do it, I just want to make sure you have access to it.
So it'll work without any hookup to the internet.
If you download it at home, yeah.
I mean, some of them you have.
Now, this one, you can download it and just work right off your own computer at home and go from there, okay? Okay, so as we start modeling now, you can see we can do stress analysis here. We can do our sheet metal right here. We have shape generators right here. We can generate shafts in here, and we'll do all sorts of things in here. We will get into correctly doing gears and not trying to tweak gears so they work. It'll make it nice for you. Rebecca did a fun little gear toy for her daughters, and it was kind of neat, but it took quite a few different reps to get it to stay together. Right, and we had to find out what the tolerance is, because printing on 3D is not like machining a part. You have to figure in a tolerance, and so that's why I say when you figure something, we might have to run a couple of test runs to see how close of a tolerance we can fit for you before you make a larger part. But we can run those anytime. Okay, that's what I'm trying to get across to you. So that's why I want you to pick something fairly quickly, and if we have to work on it, make revs, modifications of it, we can during the semester and go from there, okay? Okay, so the whole thing about modeling is, if you remember the sequence, it's extremely easy. To start a new drawing, you're just going to start a 2D sketch. So hit Start 2D Sketch right here, and then hit Start 2D Sketch again, right there. And it brings up these little... You're doing 2D sketches here, and you're extruding them to make it a 3D model. That's basically what you're doing, okay? So pretty simple. Now, the other thing I want to ask you, how many of you would be interested in this class if we went ahead and took maybe 2 weeks and introduced you to CATIA, which is another 3D modeling package? CATIA is a new software package that the school has purchased here, and it's the one that Weber State uses a lot over there. They have a couple of courses in CATIA over there. But CATIA is a software package that's used a lot with the automotive industry, with the aerospace industry. And you know, the new motorcycle company up in Park City, the Zero Motorcycle up there, they use CATIA also. And they are screaming for operators for CATIA across the country, because not many people know CATIA. So it's not like, you know, everyone knows Inventor or AutoCAD or something like that. It's a new software package. And so if you'd be interested, we can, you know, take a 2-week break, you know, from Inventor, and we can jump in and do a couple projects today, you know, together. We'd work 100% together with it in class. So we'd probably do 2 or 3 drawings a period, and we'd just kind of work it out and draw it together. CATIA's on here, yeah. Yeah, CATIA's loaded on the desktop here. And we actually have ISenSurf on here also. And what ISenSurf is it takes models, and you can kind of tweak your fillets and rounds and contours and make it more eco or whatever you want, friendly, you know, so it's easier aesthetically and so forth like that. So we do have that software on here. And so we ran a special topics class with CATIA this summer, and a lot of students did quite well with it, but that's the first time anyone's ever run CATIA, you know, there's ever been anything offered here in CATIA. So I've run CATIA for a couple of years now, and so that's why if you would be interested, we can definitely do that. The thing is, I want to get you introduced and exposed to some of these softwares, because if you're here working on it, you just as well do whatever you can and get whatever you can there. Yes.
Well, I assume part of my question is outside of the class, I guess, is there still a 2990 or a type that?
No. Now, thanks for bringing that up. Okay.
Literally in the class I need that.
This class here, 2710?
Pipe drafting for 2990 that you're citing.
Okay. So the problem we have up to now, those of you who are in the system, is we're going to do an awful lot of substitutions right now, an awful lot to account for everything. So
Like the arts class you said they can put that. Or their class.
Yeah.
and anything will count. Anything goes really right at this point.
Mine might be a little more complex of a question because I know this degree shut it down for newcomers. And I was also going to ask about the AS difference. Like, if I wanted to complete the AS part of it, is that still possible?
Yes. Oh, yes.
Aren't we we have the option of doing the old one or the new one, whatever works. That's
Right.
what I was told, whatever.
Yes.
Works best.
Whatever you want. And anything in the old will transfer to the new 100% right across the board. So we'll make adjustments for, in this transition period. For those of you who don't understand the new program is this. We've been working on this for about 2 years because Weber State has changed their program a lot over the last few years. And we wanted to make it so that students who finished their program here, who wanted to go on and get a bachelor's at Weber State, could transfer their classes and everything would transfer over with them, okay? So what we've done is we have our general eds here, right there. Now, how many of you are in that STEM 1010 class? Anybody? The new math class? Okay. Anyway, we have our general ed courses here, which is the same for all 3 different programs. We have I'll just put the drafting, the machining, and then say the manufacturing. Those are 3 different emphases, okay? So what we've done is the general ed is the same for all different areas, okay? Then we came down and we put together a core set of classes. Now the core set of classes equates to like 32 credits, approximately, right around that range. The general ed, I think, is like 11. Okay? Now, so everyone in drafting, machining, and manufacturing have to take all these core classes right here. You sign up and register, you do not have to declare which area you want to go into, because the core classes now have courses taught by each one of the instructors in the department, and they're kind of what's important for across the board for all the areas. Once you go through here, then you can decide which one of these you want to take. Now, the nice thing is, if you come down here and take that, you're going to take 4 to 5 extra classes that refer directly to this and nothing else. If you want to go to the machining, there's 4 or 5 classes here. If you want to get this, there's 4 or 5 extra classes here. Now, the nice thing about it is, within these 4 or 5 classes, there's a lot of classes that they both require. These are the classes that all 3 of them require. But some of these have 2 classes that were used here, same classes in 2 different areas. So it averages to be about 2 to 3 extra, maybe 3 extra classes you have to take to get a whole different certificate now. Okay, whereas before it was a whole long path of all these courses you had to take. So if you took 1 extra semester, you could go with a whole different certificate, get 2 certificates. Does that make sense? And so that's the way we've structured it to kind of help students, entice them maybe to get as much as they can. But everything we have here now is directly relevant to the industry nowadays. The old curriculum was set up about 15 years ago, and it's not relevant anymore. And so that's why we've changed this to help students out. And so in the transition period now, we have like our special topics, and that's where we're going to fit in all these other classes. And anything you take in this transition, we're gonna work with you on your own individual basis. After we get you into it, then we'll take a lot of that away because we want you to be streamlined in these exact courses. Okay, does that make sense? So that's how the new program is structured. Okay? Okay.
Hey, Michael?
Yes.
So one other question, are you getting into SolidWorks at all?
Yes, yes. And I will introduce you to SolidWorks in this class too. Okay? So, the what?
She said you get superior.
There, in some areas, SolidWorks outperforms Inventor and vice versa.
When you look
if
at places like GrabCAD, or some other places I've looked, it does look like SolidWorks dominates.
Yeah, and that's for a reason. There's a reason why SolidWorks does dominate, and then AutoCAD made a big mistake and let them do that.
Probably a big,
Yeah.
I don't know if Inventor does any of the simulations.
They do. A lot of companies do a lot of simulations. I do a lot of simulations for companies, and so yeah. But yeah, we'll introduce you to SolidWorks too. Now, some of you have already taken a SolidWorks class, so it'll be a kind of but it'll be a good refresher and a good introduction to everyone else in the class who hasn't maybe hit SolidWorks yet. So that'll be fine too. Okay. So what we have here, you have your axes. So this axis right here, if you look at that little cube right here, so this axis is your right side view axis. Does that make sense? See how it refers to that right side view? This one would be your front axis. You see how it relates to that? This is your top axis. And so all you're going to be doing on these different axes is you draw a picture and you extrude it on that axis. Okay? That's all there is to it. And so as we start drawing on things, you usually, not always, but usually start with your front view. Your front view, traditionally, is the view that shows the most detail. It's your plan view you start with. That's why it's called the plan view. And so most likely we will start with the front view. There will be some things that we start with the right side view and some that we start with the top. But I'll try to explain why we start with the different views as we do the different types of drawings. Okay? So if we're going to do the dovetail slide, this is our front view looking at that dovetail slide if I look where the direction of my finger right here. Okay? That'll be our front view. So if I look at my front view, the height of my front view then is going to be 2.25 and the width will be 4.5. Does everyone see that? So what I'm going to do now is I'm going to pick the plane I want to start on. So I want to pick on the front view, which is this one right here, right? See where it says XY? So just click on that plane, and it flips us over into the front view. Okay? So now, the thing about Inventor, any 3D packages, you just sketch something, and then you add dimensions in to constrain it. Okay? And so what we're going to do now is this area right here is quadrant 1, isn't it? All of our X and Y numbers in here are positive, right? So that's where we're going to want to be drawing in this quadrant right here. We aren't going to want to pass over into quadrant 2, 3, or 4, just to keep it so that, now, could you? Sure you could. But again, when things start coming together, it's a better idea and a better format to start laying out in quadrant 1. Okay? So the first thing we're going to do is we're going to go up here to rectangle. See rectangle right here? and come over here and draw a rectangle any size you want. Now you notice that I did not go down to my origin, right? Get in the habit. I don't ever do that. And the reason I don't do that is it's bit me in the past doing that. Okay? I've been with the 3D packages, well, I ran in high school back in the late about 95. And so I would do it and not worry about that. And a lot of times when I started to do my assemblies, they don't fit together right. They never did fit together right. And they would be blown off and go out and, you know, off here and never land out here. I'd have to bring it back. And so I always try to constrain it to my origin, which would be this point right here. Does that make sense? So that's how I like to do it. So I recommend that you always start by drawing a rectangle, but don't draw it on your axis. And then we're going to add 2 dimensions of 0, a value of 0 to bring us back to our origin. Does that make sense? So I want that rectangle to eventually be right on my origin. And the way I do that then is to go to dimension right here, pick your origin so it turns green right there, just put your cursor over there, click it, and then pick this side of the rectangle and come down here and click it and make that 0. Then hit the green check mark and then it'll move it right over there onto my origin in the one direction. Does that make sense? Now, I'm going to do the same thing now with the bottom of it. So I'm going to come back here, click till it turns green here, then pick the bottom of this, and then make this one 0 also. Okay, so I've constrained the 2 sides of my rectangle down to my origin now, haven't I? And I know they're constrained. Okay. So
And we'll click on it, but.
the dimension, you come down here, see it turn green right there, right?
Right.
So click it, and then click this right there, make that 0. Type in 0. And then hit the green check mark. And then click here, and then here, make that 0. See how we moved it over there? There you go.
0?
0.
Okay.
Now hit the green check mark. Now do it again.
The same,
Now
okay.
hit here.
Okay.
Now hit this one here. That's over here. Oh, so you're out of dimension. So hit it here. Now the line over here. Click. Now make that 0. Just type this 0. And then hit the green check mark. See, now you can see that together there. Does that make sense? Okay. Okay. Now, what we mentioned earlier now is that we have to constrain the other 2 sides of our box before you can move on. And that's how you get the physical size that you want. So you're trying to get a block, and then you're going to get a rectangular block, and then you start subtracting material out to get your shape you want. Okay? Because that's how a machinist would work, right? Now, let me ask you a question. Is it good practice to just add material to a model? That's not how a machinist would work, right? He's subtracting material, right? So you want to start out with a large enough one to take material away. Now, the one thing about it is, as you model and do things, you can create parts that a machinist cannot build. The one thing about modeling here, I can make that a solid part out here, and I can do all sorts of things inside of there if I want to. Is a machinist going to be able to do that? If you have a completely enclosed ball and you get inside that ball and start doing gears and everything, a machinist cannot do that, can he? And so you have to think about, how is this part going to be built? And that's how you have to design your parts. And if you can't get to it, then you have to say, okay, I'm going to build this in 2 halves so machines can do it. How am I going to assemble and, you know, fit these 2 parts together? So so you can do that. And so that's the nice thing about 3D printing, is you can actually physically do what a machinist can't do with a 3D print.
I was gonna say that.
And so, and with the 3D print now, they have a lot that you can print titanium with now. And so you can get extremely hard parts and do a 3D print of titanium, anything you want.
They 3D print houses now.
They go for this.
Yeah, yeah, yeah.
Yeah.
You're saying if the billet block was not technically a billet, but 3D printed block, how much power would hold 1,300 horsepower?
They actually, you know, I've seen a couple of race
Well,
cars that they 3D printed the complete
I think that
suspension and
was
everything on.
also
So it's there.
race cars,
They were doing inside.
their engines get rebuilt, you know, either every race or every 2 races. So,
Yeah.
so, you know, those engines get special attention. You can't just say,
Yeah.
oh, it's 300 horsepower, and, you know, you don't run it all the time.
No, they're seeing inside
You know.
per cylinder, how much the 3D printed model
Right.
actually hold the grain size.
Mhm.
Right.
They're like, you can change the grain, so their first block is 400 because you have the wrong grain growth when they're printing it. They changed how the grain growth went.
Well, that's the thing with 3D printing that I'm discovering right now. I just kind of recently got into it. You know, that's why I said that the 3D printers here are nice, because you give them the STL file and it magically does everything. But if you're doing it at home, you have to deal with a program called Slicer to produce G code, which is basically CNC code. And there are so many variables you can play with, like the layer height, the step, how fast the print head is going to move, how, you know, the temperatures, this, that, whatever, and, you know, and so absolutely, yeah, like that engine, you say, you know, yeah, pick the different grain and then discover it, you know. And that's what Mike said, that, you know, for this class, that it may take several iterations to get your part, you know, the right way, you know.
You couldn't get that deck with that deck because of the thread slip.
Right.
On the printing there, so they adjusted.
Yeah.
4 times or something.
No, I
Yeah.
mean, simple things like, you know, I have a cheapo printer, and so it's got a fan that blows on the extruder, the hot tip, and it blows on the part. And so I'm playing with the idea of using different materials that need to stay hot. So in the slicer, I have to tell, you know, or in the printer control, I have to tell and say, you know, slow down the fan or turn it off completely so that the layer, you know, adheres. Yeah, you know what I mean?
So once we have this now constrained, see how once I have it constrained, they turn black. So this says I need 2 more dimensions down here at the bottom because I have 2 blue ones left here. Does that make sense? So now what I'm going to do is, making sure dimension is highlighted, just pick this bottom line somewhere. Doesn't matter where you pick. You don't have to pick the 2 endpoints. Just pick on that line right there, and it's going to bring out a dimension line. And that should be, what is it, 4.5, right?
4.5.
So 4.5, hit the green check mark there, and then you can just use your center mouse button and scroll in and out if you want to, and hold it down and drag it. Does that make sense? And then we're going to put a height on it right here. So somewhere, just pick right here, come over here, and our height is 2.25, right? Okay. So now we've constrained all sides of our rectangle going around there. Okay. Very good. Yeah. Okay, so now once we get that constrained, you know, okay there. Yeah. Okay. Once we get that constrained now, again, this is a 2D sketch, isn't it? And so I'm going to finish my sketch because I want to extrude it to make my 3D cube first so I can start taking material away. So hit the big green check mark right here, finish sketch. Okay. Now, again, all I'm doing is using my center scroll button here, kind of position it over in the, so hit finish sketch.
I think I had to mention over here.
Okay, so put me another hit dimension. I just click there, and we just hit accept it. And there you go. Now scroll it and make it. There you go, and then hold it down and drag it. Hold the scroll button down and drag it. There you go. Okay. The what? Okay, now, what we want to do is we want to extrude this now. Now, this is critical how you do this. If I extrude, I want this surface to be my front surface. This surface right here. Does everyone see what I'm trying to talk about?
Yeah.
Remember, now that's on the front of that XY plane, isn't it? So I want that to be my very front of this box. So if I hit extrude right there, see now, is it coming out or do I want to go back?
Back.
Back. So all I have to do is see the direction right there. I want to flip it so it goes back. Now this is my front view. Do you see how you can control your parts if you do an assembly? You have to know how your assembly is going to be fitting together. So you can't just randomly start slapping parts out there with no thought about how am I going to fit this all together. You got to have a little thought beforehand. Now, right here tells me the distance right here. So what is the depth of this drawing?
2.31.
2.31, right? So type in 2.31 and then hit OK. Now you have your cube right there to start with. So that's just a plain blank that you're going to give a machinist now, and you're going to start doing features now to this to create your finished product. Now, for those of you who have not had much CAD before or drafting experience before, you dimension a part by drawing the features. So far, we've made a cube, right? We've given them 3 dimensions, their height, width, and depth, right? So you're always going to need those 3 dimensions when you dimension a part, correct? Okay, now, as we start taking away a feature, and we call it a feature. So I'm going to make a big cut coming through here. That's a feature. So you need to dimension it how you created it. Does that make sense? And so that's going to let you know how to dimension a drawing. And the view that we do our sketch in is the view that you want to put your dimensions in. So as you model a part, if you pay attention, you will know exactly how to dimension it the correct way. So the first thing we're going to do on this is, if you look at this, the dovetail slide, we have a feature with the dovetail in here, right? That bottom little notch, that's one feature. See this big slot coming through here? That big notch in there, that's another feature. These 2 little angles right here are another feature, and then our hole is another feature. So we have 4 different features on this, right? So question for you, how many sketches am I going to need to have?
3.
4.
Well, we have those slabs that can go in the same sketch now.
Right, well, we can do that or we can do that. Okay, but basically you have a sketch per feature. Now, an angle like this is called a chamfer, kind of a unique individual because we can actually do that without a sketch.
Right, it actually has a command. Yeah.
Yeah. But normally you do 1 feature per sketch. Do not do multiple sketches on 1 feature. Think of a feature or a sketch as a tool to cut that big notch across. Is it going to do the same setup to that dovetail on the bottom? It's a different setup, isn't it? Use a different sketch if you have a different feature. Do you understand that?
I located an Inventor file recently for a part and tried to modify it, And that's what I discovered, is that there were multiple features per sketch.
Yeah.
And it was a nightmare.
It's a nightmare if you have multiple sketch features
It was a
per
nightmare
sketch.
to try to, deal with that file.
Yeah. So just remember, one feature per sketch. One sketch per feature, whatever you want to say. Okay? Okay, so now again, this is my front view right here, isn't it? And I know because of that right there. This is my right side view, this is my top view, isn't it? Okay, now, as I draw this big notch in here, this big notch coming through here, what view am I going to be to give the dimensions of that notch? My front, the top, or the right side view?
Right.
The right side view. So what I want to do is I want to do a new sketch on this surface right here. Does that make sense? So all we're going to do is say Start 2D Sketch, Start 2D Sketch. Then I'm just going to pick this surface right here. And it pops that right around, right there. That makes sense? Okay, now, and all I'm doing to move this is I'm just holding that scroll button down and moving it, okay? Can everyone do that okay? Okay. Now to do this little notch out right here, what I'm going to do is I'm going to go back to rectangle. I'm going to come up here a ways and just come down here and click it in there. I don't care where I put it. I just want to create something so I can start constraining it with my dimensions. Okay? Now, when I do this, is it critical how far these lines come out?
No.
Not a bit. Not a bit. What's critical is the measurement from here to here, right? And the measurement from here to here, right? Okay, now, all I'm going to do is go to dimension right here. I'm going to pick this bottom line here. Then I'm going to pick this line here, come out here, and what should this measurement here be? It should be 1, right? So click it at 1, and then I've got to get from here to here, right? And this should be 0.625, right? Does that make sense?
Yes, sir.
So anything that's in my object now is black, right? It's constrained, okay? Anything outside of it, I don't care about, because that's where my cutter's going to start, and it can start close, it can start far, it can come in any way we want to mill that out. We good there?
Okay, I was learned by my mistake. So I have mine in the 3D, looks like, and we said this is the right side,
Okay.
is that correct?
Okay. Let's see here. Okay, that's the right side, so, okay, so we finish the sketch here now. Okay, here, and we're going to extrude it,
Okay,
and we're going to go back.
okay,
So there it is right there.
okay.
So now you're going to want to start a new sketch on this surface here. And then we can draw a rectangle now right here. And then you can add a dimension now from here to here, and that's 0.625.
Point.
And then we go there, and then from here up to here is 1. Okay, and there it is.
Okay. So this, where would you say I missed? Why was that?
You started another sketch. See, you should only have
before I went
2
to-
sketches, but you're on your 3rd sketch now.
Oh, okay, I guess it is. So, okay.
Right. Does that make sense
So
now?
extrude, so, okay. Okay.
Okay?
Okay. That's it, but it'll fall in.
Yeah, it will. It will. It will. Okay? Okay. So now, once that's finished there, I'm going to finish my sketch. So finish your sketch right there, and it should pop it into that orientation. So now what I want to do is I want to cut that through there. Now a machinist is going to mill that first thing out right there. So what we're going to do now is, and this is where I wish that they would have their own little tab, but the cut tab is buried in the extrude command. So if you'll go to extrude, and then cut right here. See where it says cut?
The little square, yes. Okay.
Cut right there. And then see this right here. See, this is what's changed between 2019 and 2020, isn't it? It's a little different right here. What? It's new and improved. So here's through all right there. And then just hit OK. And that's your first notch, your first feature cut out there. Okay? Did you get it there? Good. Now hit OK. You got it. Be sure to hit through all. Yeah.
Okay, so this was the cut, and then
That's
this is
through,
the cut through it all?
Yep.
Okay.
Now hit OK.
Okay.
You got it.
Okay, so.
Now, that sequence of commands is the same sequence on everything you do. Yeah.
Okay, cut through, okay.
And we have to cut through all, you know, maybe to a different feature or a distance and stuff like that. Okay? Does that make
Where they're
sense?
at, and then,
So this is totally new from what 2019 was, isn't it? And so, yeah. Okay, now, that's our first feature. So if you look over here now, okay, so we have our first feature. Now, let's do these little chamfers right here. Okay, now if you look right here, here's a chamfer command right there. Do you see it? So hit chamfer. And our chamfer command is just like it is in AutoCAD. You have a distance here, so you can give an A and a B distance. Here you have a distance and an angle command. And here you have two different distances. So this right here is a single distance, means the chamfer would be like a 45 if they're both 40, you know, the same measurement. The bottom one is if the chamfer is not a 45, it's a longer angle. And then the middle one is a distance and an angle. So you can do it numerous ways. But if you look at this right here, okay. The distance here now, if you look at the drawing here, that chamfer comes over 0.75 and it's a 45 degree, right? So we're going to go with a distance and an angle. So click on that little icon right there. Our distance is going to be 0.75, isn't it? And the angle is 45, right? And all you need to do now is click that little line right there. Okay, we'll go with that face there.
Twice.
No.
Turn green and then.
There like that. So you have to do the chamfer a little bit different too.
Ah, okay.
Okay?
But
Then
which side did it pick as the 0.75?
it's whatever you want to go to, but you got to remember now. I picked this face here first and went 45 from
But
that
it's 45,
face.
so it'll be 0.75 on either one.
Yes. So you pick. It's just like when you dimension. Remember when I told you to dimension? You dimension from the surface, and that's where you give your angle from. So it's doing the same thing for us basically here.
Oh, Mike, you know why it was not letting you select the edge?
Why?
You will see that once you click on the chamfer command again.
Mm-hmm.
You see it says edges
Uh-huh.
and face. It does not let you select
Right.
edges.
Right. Yeah, and it used to in the last year in the summer version. A week ago we could have done that. And so here you go. We want to click there and there. So it's just a little tweak in the way you do the commands. That's usually what all the changes are. Someone didn't like the way they wanted it, and they wanted it referenced off of a plane. And if you do that, you know, that's where your dimension goes off of that plane that you're referencing from.
I have a bachelor's in computer science, and one of the courses I took is in the on the usability engineering, which is basically how do you design user interfaces. It's a whole doing it the wrong way.
I believe it.
And the industry is using that as well. So that's why we have crappy user interfaces, because the actual designers, the people that really can come up with good user interfaces, they're usually not part of the team.
Right. So now what we're going to do is we're going to start another sketch, because we're going to go to a new feature, right? Okay. So what you're going to do is start 2D sketch again. Hit start 2D sketch again. We wanted on this surface right here now to do our dovetail, don't we? See how it pops right up in there? You see how we're in quadrant 1? That's how we constrained it, wasn't it? Okay, now I'm going to show you how to stick this dovetail in that might be a little different for you, but it's a thing that I found that works very good over the years, okay? If you don't do this, it's a possibility of having something not constrained correctly. And that's why I'm going to show you maybe a little different way. You might say, well, there's an easier way, but I'm going to do this with the line command. So I'm going to do a line command, and I'm going to sketch this. I'm going to start from here. I'm going to come up here straight. I'm going to come in here at a slight angle, come over here. I'm going to come down to here, and I'm going to draw something like that. Does that make sense?
Yes, sir.
So you're just sketching it in.
I'm just sketching it in there, yes. And then I'm going to constrain it with my dimensions. Okay? Does that make sense?
Yes.
Except one thing. Here, let's undo it. And let's do undo. I'm going to go to a line. I'm going to come down here, come like this, come over, come down here, and like going across. And you have to directly in line right here. So I'm going to draw something like that.
Okay.
You want to start a new sketch? Yeah, so it's here. Yeah. So you come here, start there, put that thing. Okay? Go up.
Maybe I'm just I have to kind of years out. I mean, you're good, I can tell already, and I got it.
Right. Rex is honestly in here. No one can figure out how it goes.
Well, that's my.
I'll be there.
No, so well, yes and no. I'm gonna have to be present with all of them. But that's fine. As long as you can get this class and go for it, and you submit them, and you guys put, I got 3 credits, right, then I can perform it. So now,
Yeah, you do the sketch like I was trying to get to be. So you have to start the line now. Start the line. Okay. Down here, you come down here, up here, you gotta do it.
Once you see your 7,
Yes, yes.
so the thing
For
like,
mine, well, I actually. My background, I went to university, is civil engineering, architectural drafting, income. So I have a bachelor's degree in applied science.
You know, you do that sketch.
So I've been taking. we use method at work. So,
Okay, once we have this now, the reason that I do not have these points right here, right on here, I want to lock those in with a dimension so I can control and make sure that goes right on that surface instead of trying to draw it, because sometimes it might not work exactly like you want it. So we can do a couple of things with this. First of all, this point and this point are not at the same elevation, are they? So if I wanted to, I could come with dimension. I could pick those 2 points, that point and that point right there, come over here, and I could make that to be a 0 dimension. Now they'll be moving together. So I move one, the other one will move up with it, and I know that they're going to be on the same plane. Does that make sense? So can you see the advantage? A lot of times if you try to make something so it's at a right angle, if something's off on a setting, it might not be 100% exact. It might be a couple of thousandths off, and then it's not going to work right. And so that's why I control those with the 0 dimensions. Okay, the other thing now, so if we look at it now, we know from the bottom here to this top right here is a 1/2 inch, right? So make that 0.5. Are we with me okay?
no. So, okay, I'm on. A little behind them. First, doing my dimensions, sorry. Once I get the hang, so
From
I
there
got there.
to here.
So I'm just gonna click on both, okay?
Oh, now move to, you had it right, you had it right.
Okay, so
There.
it's gonna highlight these lines, okay, you wanna make sure.
Now move down, now move down, click it. You got to
Oh,
click it.
click, that's right.
Now make
Okay,
it 0.
good. Okay.
See, now,
There
what's
you
it? Here now, there you go, click on that number, I got 0. There you go, now it's 0.
Now we're going back to the,
Now,
okay, we got it.
this one, and here is a 1/2 inch. 5. There, now, look, I can make the next count right here, here. I want that to be what measures. I want this to be right on that line. 0. I said 0. It's this side, because I have those things together, this side. Does that make sense now? Now we're going to get that angle worked out.
I know. It'll all click here.
It will. Now, how far is it from this surface here now over to this surface here? 1 inch. Let me hurry and grab this dimension. From here to this point here is 0, right? Now, from here to this line here now is 1, isn't it? That make sense?
Yes, sir.
Now, watch this now, everybody. Don't do this. Let me make the mistake, okay? If I go ahead now and dimension now from here to here now, that should be 1 also, right?
Right.
See how it distorted my shape? So let me show you how to.
Because you didn't dimension the angles yet.
Right. Now,
If you had, then it would have.
Right. So I can add a dimension from here to here and just stick that in now as a placeholder. And then I can click here and make that 1. See how it did distort my shape by doing that? And now I can go back and edit that angle, can't I?
Okay, can you show me that again, please?
Which part of it
So
now?
your angle, where you put your angle
Okay.
in?
Okay, so let me hit undo right here. And
Okay,
we're going to go to that part, okay?
okay,
So what I'm going to do is I have this 1 inch from here to here, right?
Yeah.
I need to have 1 inch from here to here also, don't I? Okay, if I put a dimension now from here to this line right here now, that should be 1 inch, right? If I type in 1, my angle kind of disappeared, didn't it?
Right.
But I want my angle to stay intact, and so I'm going to put a placeholder in there before I do that 1 inch. So what I'm going to do here now, I'm just going to hit undo here. Then I'm going to go to dimension, and then all you have to do is click that line and this line here, and just click it and accept that. And now look, as I come in here now, I can change that now to 1 inch, and it doesn't distort my angle, does it? Can you see what I'm doing? I'm trying to keep the integrity of my sketch, because if you put other dimensions, it might just invert your sketch the opposite way completely. But now I've got to go back and change that dimension, don't I? And that dimension should be, what angle do you think? 60. That should be 60, right? That makes sense? And then I'm going to add an angle from here to here now, and that should be 60 also, right? So everything within my sketch now is black, so it's totally constrained, isn't it? Okay, so see you went from here to here, so let's go undo. There. Now I'm gonna put this at delete. There. Now let's add a dimension now from this line to this line here, and move this way here. So you move that out there. Just type in 60. And there you go. And then you just go from here to here, and we're getting not out there, it's in there. Okay, so type in 60 there. There you go. Now, what you haven't done now is we need to get here to this line here. That needs to be 1. Exactly. See, now that we have our angle in there, it doesn't distort our shape, does it?
First, we
right.
did them
That's
together,
right.
and I did my opposite first.
Does that make sense now? Okay. Okay. So now we have our sketch there, right? And so I'm finished up with my sketch. So hit the big green check mark right here. And now what we got to do is we got to cut this feature through here. Okay, so go to extrude. And we're going, see, this one is join, this one we want to cut, right? This is intersect and so forth. So you can do different things with this, but we're going to cut, and then we're going to do through all. Now, the thing about this one is, before you could pick here and it would pick the whole sketch, we got to pick there. And it cuts that through.
Right.
So it's a little different. The setting up is slightly different from the old version.
Yeah, I was also surprised that it separated them.
Yeah.
But is this too early of a concept to talk about the fact that when you did the 2D sketch with the lines, that you ended up connecting the
Right.
beginning of the first line
You have to
and the
connect
end
the
of
two
the
lines
last,
together.
which ends up in a block or
Yeah.
you know,
Some shape.
a shape,
In a closed shape.
you know, not just individual lines,
Right,
because
right.
otherwise the extrude command would not work.
Does not work right.
Right.
That's right.
So, but that may be too early to
Yeah.
discuss that yet.
So did you get that done?
Let's see, it looks like it cut through, so I'm going to extrude. I thought I had.
And then cut.
So I have to hit the base of it. Oh, but then the line has to go in. Wall and
Yeah.
over.
You got it.
Yeah, I just.
Okay, that makes sense?
I'm like a three, and then it is
So
in bed.
go to what? Gotta go from here to here, make that zero.
Yeah, it takes several times. Yeah.
So the dimension now.
2 or 3, and then 3.
Take that bottom line there. Now take this point here, right there. Make that 0. Now you gotta get from here to here at 1. Yeah. So dimension is go from there to there. That should be 60. You bet. That's what that'll be. And then this has to be 60 also, then you have a 1 there, right? Does that make sense? Okay. So now, if you think about it now, if you look over here at this browser right here, we have our extrusion. What was that extrusion? That was our first extrusion, wasn't it? See how it's kind of highlight? Can you see my highlight there? Extrusion number 2 was cutting that one notch out, wasn't it? Hey, Rex, I'll be right there. And then we have a chamfer and a chamfer and another extrusion, right? Okay. Now, save this off. I've got to go talk to Rex for just a minute. It's about our 2650 class tonight.
Oh, is that the?
Yeah,
Are we meeting?
that's what we're going to find out right now.
Electronics?
No, 2650. So give me just 5-10 minutes, and so save this off, and maybe even try to start it again yourself, or try doing the dovetail finger on your own. So have 2 files going and try to do the dovetail finger. But let me go talk to Rex for a few minutes, okay?
Oh, okay, right here, finger. Okay, so that would be the big Oh, okay. Then, so I just don't know if that's saying, oh, that's the problem. We'll try again and is that something that you? You can find somewhere there. I'm saying, yeah, I know that's not the way. So I'll look in here, so. If you know how to find it, do it online. Sure, I'll look to see, I put my name here for a few, and then check it out. Yeah. Okay.
I would just call it, just, or whatever.
Oh, yeah, okay.
That's what I do.
Yeah.
That's how we get it. Yeah, just start with right in the file. And you can do this, and then switch photos, and then some, and then watch. And then just have it over, have it over. And then you click. The first thing you do is and then click on the so that you want to, so on the, you gotta pick which one. Oh, you know you don't want that one. Okay, that's the next one. There. And you're ready.
And